this video, we're going to talk about linear equations. So suppose you have some data on a tomato plant and you recorded its height every few days. And you recorded that day 1, it had a height of 0, day 3, it had a height of 4, and so forth. So you could go ahead and go to some application, GeoGebra for instance, and you could plot this data on a graph as you see here. And you could draw your line of best fit just like we've been doing, kind of estimating that there should be about as many points above and below the line, kind of averaging the points. Now if we want to find the slope of this line, there is an equation to do that. So the slope is y2 minus y1 divided by x2 minus x1. So in order to find the slope, you need 2 points. But you don't want to actually choose the data points. You want to choose points that are on your actual line of best fit. Well, if I look at A looks like it's right on my line of best fit, so that would be a good one to use. So I would have to pick another one on the line of best fit. And if I kind of go up on the line, I'm looking for one that fits evenly into kind of like the crossbars of my graph. So this green one here looks like a good one because it's right on the 10, 20 line. So point A would be 1, 0, and point H, I don't have a label for it, so I'll call it point H, is 10, 20. So now I have 2 points that are on my line of best fit, and now I can calculate my slope. So it doesn't matter which pair you call 1 and which pair you call 2. So I arbitrarily chose my A to be x1, y1 and my H to be x2, y2. Now that I've labeled them, all I have to do is plug them into this equation. So my y2 is 20, my y1 is 0, my x2 is 10, and my x1 is 1. Now I just have to do the math. 20 minus 0 is 20, and 10 minus 1 is 9. So my slope is 20 over 9. But let's remember what this is telling us. Our y's was the height in millimeters, and my x's were days. So if I were to say, well, what does the slope mean? It means that on average, the plant will grow 20 millimeters every 9 days. So let's now also figure out how we can find the y-intercept. The y-intercept is where your line of best fit crosses the y-axis. So if you go all the way down your line until where it crosses the y-axis, you'll see it crosses right here. So it looks like it crosses at -2. So now I know my slope of my line and I know my y-intercept. I can put them into my equation y equals mx plus b in order to get the equation of my line of best fit. So my slope is 20 over 9 and my y-intercept is b. So this equation y equals 20 over 9x minus 2 is the equation that would model the growth of my little tomato plant. We can now use that model to make predictions about the plant's growth. So let's see how we can use this equation to predict how big the plant will be in 30 days. There's my equation. And the question is saying, if x equals 30, what is y? Well, I'm going to change that 20 over 9 to a decimal just by putting it to my calculator, saying 20 divided by 9, because it'll be easier for me to calculate. I plug the 30 in for x and go to my calculator, and I'll get 64.6 millimeters. So that's how tall my plant would be in about 30 days. So will this model always predict accurately? Well, let's use this equation to predict how big the plant will be in 365 days, in 1 year. So if x is 365, what is y? I can certainly calculate that. I can just plug in 365 for x, and I'll get 808.3 millimeters, which is about 31 inches. So that seems to make sense, But what are we assuming here? Is my plant still going to be alive in a year? Is it outside in New England? So even though I can actually calculate a value, you still have to kind of ask yourself, does that make sense?